So let's talk about serving imagery as web services, or how can I use raster data in my web map? Well, first of all, let me ask this. Why serve imagery in the first place? Well, to us GISers, we probably already know that answer or have an answer almost ready to go. But that's the share data. We want to share data with the GIS community. And one thing I've noticed about this GIS community, and it's not just in Idaho, it's every place that I've been, the GIS community likes to share data. And we know from past experience that our lives are easier when we can access data from others, real good data from other people in that GIS community. And so I think a lot of us feel that desire, let's say, to share back with that same GIS community. That's certainly a good reason to serve imagery. It also eliminates the need of downloading data. Why do we have to have all GIS data stored on our own hard drive? We really don't need that. That's kind of an antiquated notion. Now, yes, sometimes we do need that, but many cases we don't need it. As long as we have reliable internet connectivity, which most of us do, then we can use GIS data served as services. And in particular, I'm talking about imagery, raster data as a service. Raster data tends to be really big stuff. So why not stream it in instead of copying it down to our machines? Really, serving imagery, all the same reasons why we would share any GIS data as a web service, whether that is vector, points, lines, polygons, or raster data. Lots of compelling reasons to share that data. A little bit on terminology or semantics. Imagery, maybe a little bit newer term, is simply raster GIS data. Raster layers are spatial data organized in rows and columns. Almost looks like a checkerboard. They're always rectangular in shape, always rectangular in shape. Some file formats that you might be familiar with are the TIFF, wonderful file format, tagged image file format, very good for our GIS work. IMG, also in use quite a bit still today, not as popular or as common as TIFF, but that's the ERDOS Imagine file format. RST is the Idrisi tear set or Idrisi raster file format, RST. And then a lot of us are familiar with JPEGs and PNGs. Not really a good GIS file format, simply because especially JPEG is lossy. But we're also probably very familiar with JPEG, so I threw that in. Rasters are a very common type of spatial data. All spatial data, for the most part, is vector. No, it is all vector or raster. That's it. And for the purposes of this presentation, I'm going to differentiate two different types of raster data. Let's take a look at those. The two basic types of raster data that I'm going to be looking at, talking about, is what you see is what you get. There's a screenshot of some NAPE aerial imagery, and it is what you see is what you get. Greens and browns and dark water types of things, a little bit of white we can see up on the mountains here. It's what you see is what you get. In contrast to, now I made this up, pixel values are important, PVAI type of raster data. And yeah, we can see in this topography layer here from some LiDAR that we can see that there's some differentiation, some greens and some browns and yellows in between. We're not necessarily sure which one's higher and lower, other than interpreting it as green is usually considered lower and the browns would be considered higher elevation. By the way, these are not the same exact areas. Now, pixel values are important. That is where what we're really interested in is being able to click on a given pixel, and then we see the elevation value. This is the pixel that I clicked on when I did this screenshot, was at an elevation of 1,856.65 meters in elevation. So in that case, pixel values are important. If we clicked on a pixel value over here, we would simply see the red, green, and blue values, not really telling us anything too much about that other than that's how we got that shade of green or that shade of brown. That's it. So very different types of raster data, but we can serve both. I'm going to focus on the pixel values are important imagery because they're actually a little bit more difficult to serve. And if we can, if I can talk you through the process of serving this type of raster imagery, the same general process is used for any type of raster imagery, even if it's a little bit simpler in some cases. Okay, how do we serve imagery? Step one, you're going to need ArcGIS Online with ArcGIS Image Licensing or Enterprise Portal. So if you don't know if your ArcGIS Online has the image licensing, you can go into that ArcGIS Online, and this is what you'll see. You'll see ArcGIS Image for ArcGIS Online, the number of individuals who've been assigned access to that license, the number available, the number in total, and all the good stuff like this. We have it here at ISU, just recently got it. We're not really doing too much with it, as you'll see why in just a little bit. Step two, your user account in ArcGIS Online or in Portal will need permission to use ArcGIS Image. Notice that, in other words, your account needs to include that image extension if you're going to be allowed permission to share, as they call it, used to call it publish raster imagery. Step three, assess your imagery. What do we have? What are you trying to serve? Is it a single raster file that you want to serve, one TIFF file, or are there many raster tiles files that you want to serve and make them look, act, and feel as if they are one raster? We're going to tackle, again, the more difficult method. We're going to go after the tiles. If you can learn how to serve a group of tiles, raster tiles, then you can certainly serve an individual file. So it's a little bit harder to do it this way, and we're going to tackle that one purposely. Now, your stack of raster tiles can be what we call a spatial stack or a horizontal stack. That's a synonym there. Or it could be a temporal or vertical stack of raster tiles. Or it can be both, spatial and temporal, horizontal and vertical stack of files. Let me explain what I'm talking about here. Here is a spatial or horizontal stack. Now watch this. There's a little bit of imagery, one tile right there in Pocatello, Idaho, right around the campus. There's our second tile, third tile, fourth tile, fifth tile, and sixth. There's Holt Arena showing right over here, the mini dome. There are 6 tiles in here. We want to serve them as a stack to make them look, act, and feel as if it's just one raster layer. Now compare this with a temporal or vertical stack. This is NDVI satellite imagery with a kind of a bright, almost gaudy color that we applied to it, but it's fine. And as you can see, this is American Falls Reservoir. Many of you are probably familiar with that. And Craters of the Moon, right over here, National Monument. Okay, so this is one shot in time Landsat imagery, early spring from last year. A little bit later in the same growing season, covering the exact same area. The only difference is time, the time component here. So that's why we call it a temporal, or if you can imagine it as a vertical stack. So it doesn't matter what type of data stack we have, we're going to serve it in the same way. Some folks call that a data cube. To do this, we're going to use the file geodatabase and Mosaic dataset. So now we're on step 4. We're jumping into ArcGIS Pro. and we're creating a file geodatabase, fGDB, and Mosaic dataset. Now, by the way, I prefer using Portal for this sort of work instead of ArcGIS Online. I did a little bit of experimentation, I believe it was last week, and when we serve our imagery with our image service license to ArcGIS Online, we are consuming 100 credits per day per gigabyte of data that's being pushed out there. You may think, well, gigabyte, that's a lot of data. Well, maybe not so much when we're talking about raster data. So a little bit of FYI for you there. I also saw some performance problems. I was getting that giant black and white checkerboard for days after I published the service. It really wasn't performing very well. Did not see any of those sorts of problems when I'm publishing to Portal, and of course your own portal, your organization's portal will not have those credit restrictions. So I just launched a brand new ArcGIS Pro project. I created a new file geodatabase right over here, new file geodatabase, and within that file geodatabase, I created a new Mosaic dataset. So new Mosaic dataset. Now, some notes on the Mosaic dataset. I shorthand that as MD. Spatial Reference System, shorthanded SRS. Now, your source raster layers need to have a correctly defined spatial reference system. When we work with the NAPE aerial imagery, that's about 6,000 plus tiles of TIFF files that look and act and feel as if they're covering the whole state of Idaho as one image. That's what we're ultimately creating when we work with that imagery. Some of that imagery is in UTM zone 11 north. Some of the imagery, almost half, is in UTM zone 12. Well, as long as all that imagery is correctly defined, the projection is correctly defined, that's great. Okay, now when we create our Mosaic data set, the spatial reference system that we use for the Mosaic data set does not need to match any of the spatial reference systems used by the source raster data. In other words, I don't need to choose UTM zones 11 or 12. In fact, when we serve the NAPE imagery, what I do is I use Idaho Transverse Mercator NAD83 as the spatial reference system for the NAPE Mosaic data set. Step 5, once we've created the empty Mosaic data set, step 5 is to add rasters to the Mosaic data set. So let's say what I have here is a folder, and I like to do this. I like to create a folder that I normally call Rasters. Works out really well for a presentation like this too. Here's a little bit of file management tips. Move the raster data into a folder, all those files, move it into a folder within your ArcGIS Pro project file, a project folder. That makes file management in the long term much, much easier. So here is my project. I called it Unclassified Fire Severity, part of our ongoing NASA Recover project. I have a DNBR geodatabase in here. That's the difference normalized burn ratio geodatabase. I have a Mosaic data set called Unclassified Fire Severity. And then I created a folder called Rasters, and I copied into it 6 DNBR TIFF files that exist across the Western United States, large wildfires that burned in 2022. Okay. This is my source folder. Once the add rasters process is complete, you can't delete this. Don't delete, don't go, well, I completed the add rasters geoprocessing tool. Oh, it's done now, so let me go ahead. These are such big files. Let me go ahead and delete the rasters folder. Oh, don't do that, because the Mosaic data set is simply referencing these files. It's not ingesting these files into the geodatabase. It's simply referring to them. So don't delete them. Step 6, view the finished Mosaic data set. Kick the tires, zoom in, zoom out, pan around, check the return pixel values in a pop-up. This is important stuff to make sure that the Mosaic data set is really working correctly. And when I say zoom in and zoom out, I mean really, really zoom in to about a representative fraction of 1 to 1,000, maybe 1 to 500 or so. You want to make sure that that Mosaic data set is correctly delivering raw pixels when it needs to, because one of the processes of the Mosaic data set and that whole add rasters process is it will build overviews. It'll calculate statistics, pyramids, and overviews. And when you first look at the finished MD and you're zoomed out to 1 to 1 million or 1 to 500,000, oh yeah, there it is. There's the whole state of Idaho with my NAPE imagery. Boy, it sure does look great. But as you zoom in, there's a certain point where you will no longer see overviews. Overviews are essentially screenshots. But then at that point, when you're zoomed in really close, the Mosaic data set should be returning to you actual raw data pixels. It's going to go to those source data and stream those into you, even if it's on your own computer while you're first working on this. Make sure that everything's working perfectly. Step 7, think about adding some processing templates. This is obviously an optional step, but it can really add a lot of value to your data. For example, with our elevation image services, we have one based on NED, National Elevation Data Set, that we serve, and another that's based on LiDAR for the state of Idaho. Well, consider adding the following processing templates to that Mosaic data set. For instance, aspect, slope, hillshade, there's others. Consider those sorts of things. Whatever your source data is, think about how you want to use it and how others in the GIS community might want to use it. This saves a tremendous amount of additional processing, because the end user, you also, you can, in an instant, change that elevation image service to work with aspect or slope or whatever you want. No additional data is written to the hard drive. It is all done in memory, in RAM. Very, very powerful tools we can take advantage of. Now, how do you do this? Okay, what we're going to do is we're going to use the manage processing templates for the Mosaic data set. And what I've done is I have right-clicked on our Mosaic data set. I'm choosing manage processing templates. That opens up this pane in ArcGIS Pro, and I can click on this orange button right here to import processing templates into my Mosaic data set. What is a processing template file? Well, it's just an XML file with instructions to ArcGIS Pro or to ArcGIS, I should say, on how to deal with that data. What is this thing trying to tell it to do? Well, I wrote a custom processing template file called meters to feet. As you saw earlier, that raster data for elevation was expressed in meters, 1,800, if I remember right. Meters were shown in that pop-up. Well, let's say the end user wants to work with elevation in feet. Well, it's easy. They simply apply the meters to feet processing template, and this is what it looks like right here. Actually, it's a pretty large processing template. A lot of them are only maybe a dozen lines or so. But what it's doing is this thing right here. It's telling ArcGIS Pro to apply a scalar function, multiplying it by 3.208. You can see it right there. So it's taking those pixel values that we know are in meters, multiplying it by that value right there, and it simply converts that value into feet, because that's the conversion factor, and that is what the person sees and works with from that point on. Step 8, we're going to analyze the Mosaic data set, or we're going to tell ArcGIS Pro to analyze it. So we're going to use the Analyze Mosaic Dataset geoprocessing tool, and we're going to fix errors, the big red errors. We're going to fix them during this analysis or right after the analysis process. One of the common errors that we see is this maximum number of rasters per mosaic. It's not large enough. Gee, I wish it would automatically be fixed for us, but that's one we see oftentimes. And those are so easily fixed by using the Set Mosaic Dataset Properties tool. It'll open up all the different properties for a given mosaic data set. We'll scroll down, find the setting, maximum number of rasters per mosaic, pop it up from its default. I think it's defaulting normally to 24, 48, typically fixes it. In fact, that's a recommendation that you'll see if you look up the help on that sort of error. Pop it up to the correct value, analyze it again, and it'll come up clean. Step 9, by the way, there's only about 10 steps. So we're almost done. Step 9, share the final mosaic data set. Sharing to your portal is easy and performance is absolutely excellent. We're simply going to right-click on the finished mosaic data set and choose Share as Web Layer. Now, we share this through Catalog, not from the map and those buttons across here. We share it through Catalog. And this will, as long as we're connected to our portal, we'll be sharing it directly out to our portal. Now, a person could say, well, hold on. Why not just mosaic those 6,000 files together, or those 6 files together, something like that? Well, if all the tiles are contiguous over a small area, creating a new, larger TIFF, it's okay. It's okay to do that. But if the tiles are not contiguous, or if the total area is large, the entire state of Idaho, okay, or the final file size, once you do mosaic it, is really, really large. TIFF has a practical limitation. After it gets a certain size, oh, the file will write, no problem, but it won't work well. It just works terribly inside of ArcGIS or any GIS software. And in some other cases, what are you going to do when the tiles overlap? Right? In some cases, you do not want blending to happen, those sorts of things. For any of those instances that we're seeing right here, the mosaic data set is a far better choice than simply running mosaic as a command to put them all together. Performance will be far better, and you have much more control over how that data is used. So here's an example. Mosaic with non-contiguous tiles. I have one LiDAR tile right up here. I call it tile 1. It is 8.5 megabytes in size. Another tile right down here, tile 2, it's also 8.5 megabytes in size. Well, I can serve this as a mosaic data set and an image service, but let's say I decide, well, I'm just going to go ahead and mosaic these two together, and I'm going to serve that one TIFF file out. Okay, so I did that. There's my resulting mosaic. And I have one TIFF tile here. That's data. Everything here, this is all data right there. All this green stuff, no data, but it's all pixels. And it's all taking up space. Now, my TIFF file is 55 gigabytes in size compared to 16 megabytes in size. What a tremendous savings and gain in performance. Need I say more? The mosaic data set does not fill the voids between your tiles with no data pixels. Performance is greatly improved with that mosaic data set. Step 10, keep the service current. Tips from the trenches, if you want to call it that. You'll very likely receive new imagery to add to your image service. New LiDAR imagery, for instance, or some additional fire severity DNBRs for 2023. Easy thing to do, right? Following those same steps, my recommendation, tips from the trenches, create an entirely new mosaic data set. So for my LiDAR imagery, what I have here is I have I create what I call the Bare Earth Mosaic data set, and I'll name that Bare Earth and then a timestamp or a date stamp. 2023, February 10th. I revised it 2023, February 14th, and then I missed some files or tiles. So I said, oh, I got to do it again. 2023, 02/15, so February 15th. Then once this one's done, this is the most current, let's say, and we got some new stuff coming out though, by the way. This one's the most current. I'm going to right click on this one, and I'm not going to share it as a web layer. I'm going to overwrite an existing web layer, and it just goes right over the top of the existing web layer. No URLs change on the user's side, and you have just made a brand new image service with the most current data, absolutely seamless to our end users. Okay, I hope I did all right on time. Let me see. I got a couple minutes. Are there any questions?